Hey, Simon, switch off your cameras, okay? So, because otherwise I can't share the video. All right, yeah. Well, I thought I made that the default now, because previously when you joined the meeting by default your camera would be on, but now it's not. In fact, no, hang on. Yeah, in fact, I can just go to speaker view or something even, because the gallery doesn't even make sense anymore. Um, All right, okay. So how come my focus is on Simon rather than I'm talking in the highlight? Is that how it appears to you guys too? Right? So I'm talking up here, but Simon's window is in focus here in the middle. Is that how it looks for you guys?
Not for me.
No.
No? All right. Oh, now I got Eric. All right. So I see. It's the last person who talked, right? Except for me. All right. Okay. Why is it not picking up that I'm talking and put me in here in the middle? Okay. All right. Speaker. How about immersive? Let me try immersive. Yeah, okay, let's try this, okay? I mean, I think I tried it once before and a long time ago. I forgot what it is like, but maybe it's changed now. Place participants into the view automatically, manually. Automatically, okay, start. Wow, what's going on here? I'm in one of these
What?
frames. I'm in one of the frames, right? That kind of looks crazy. Maybe you got to get used to this, okay? Or I don't want to experiment with this in class. I'm going to go back to the regular view. Just give me a sec.
I mean, it's quite interesting actually.
Hmm?
It's quite interesting. This is the first time I see this view.
Yeah, me too. Yeah, it's interesting, but it could get old very soon. But anyway, hang on. Yeah. All right, I need to switch to another view right now. Uh, yeah, in that view, I couldn't even tell who was talking. I think I could tell from the voice. I think it sounded like Simon, but I couldn't tell that it was Simon. All right, stop immersive view for everyone. Yes. All right. Now back to Simon, and I think I'm just going to go for gallery view like before. This is probably the better thing. You just keep your cameras off for sure. And this is okay. And as soon as someone shares a screen, it'll be fine. Because it doesn't matter. Yeah. Whether your camera is on or off. Anyway, I hope you had a chance to what time is it now? Yeah, okay. So I hope you had a chance to look at that post. And by the way, you know what? Next week is week 11. And let me get hands up or something, that thing in the icon. If you want I'm thinking either Tuesday or Thursday, we could meet in class, but not under, if some people don't want to meet in class, that's okay. We'll just do everything in Zoom. That's fine. But if you all want to meet in class, or if there's a significant number who want to meet in class, we'll actually meet. I think I would prefer if it was a Thursday actually, because then the Thursday would be the week before week 12, your finals. And in that Thursday class, you could actually reflect on the entire quarter, starting from day one, when, hexadecimal and bits and bytes, all the way to what you're doing now with pointers. So you can reflect on the whole thing, not from the perspective of CS2A or this class. You should just reflect on what it was like, what you felt like, because I think, 12 weeks is not a big deal. If you let it lie and then you go on to, do work or future studies elsewhere, and then it'll be harder to remember what it was like now, right? So now is a good time to checkpoint and basically think about it one more time, so it'll kind of stay in your memory, so you'll have a good idea of calibrating how you can do things, because you are the best judge of how much energy you have, right, during that time, during the 12 weeks. And you know what you got for how much energy you put into it, so you can actually calibrate future things. But a lot of people, I think, just forget and just keep going ahead, looking forward only. And then that is much harder downstream, because you won't have a good calibration for how to pace your effort when you have a lot of effort to spare. All right, okay. All right, so here's the idea that I shared, and I think it works really nicely in my mind. Okay, and I think we will also try and use the trick that Isidore. Where's Isidore? Isidore is here today? Yeah.
Yeah,
Okay.
I'm here.
Yeah.
I'm here.
Oh yeah. So yeah, he posted something in one of his posts. I think he said something about set W. Okay, with IO manip, right? So and I think we'll use that to good effect today. So and I think combined with the tricks that we've learned in the past, which is to use sleep and /R to overwrite the same line. Yeah, we can have a pseudo animation effect, right? Without even active cursor positioning, just only C++. I think we've done this before. If we haven't, I think it'll be a great experience. Okay, it'll be really fun, and so that's fantastic. Okay, yeah. All right. So all right. So how about what are we going to do today? Yeah. All right. So we can well, we can actually start from scratch. Really, we can create. Yes, I think. How about this? Okay, we don't have to pick up the code from last class. How about we just start from scratch and just throw in a node and a pointer, create a linked list, and you should just be able to do it. Even if someone wakes you up at 2 a.m. and say, "Hey, give me a linked list in C++," bam, you should say, "Hey, all right," and then turn around and go to sleep. Yeah, okay. So so we just have to do it. And you'll see there's no magic to it, right? You just commit something, and it takes less bytes in your memory, really, once you get to know how to do these things. So let's just do this, even if it's just for practice. Let's not, for the remainder of this class, really, let's try our best not to go from previous code, right? In fact, I would suggest that, let's say, for example, Vikram or Ben or Akira or Isidore, whoever it is, right? Share some code. And I think that most of them say, all right, here's my code, fork it and make some changes. I think it would be well worth your time. Okay, this is a recommendation. It's a strong recommendation, right? Just not to fork it, but to read the code and then just reproduce the behavior yourself. Okay, and just use that as a reference. And I think that would be much better. I don't know if you have the luxury of doing that, given all the other demands in week 11. But I think that is the best way to do it, rather than just fork someone else's code. You can actually just do it your own way with your own twist, right? Okay. All right. Okay. So that's what we're going to do. All right. Okay. Hey, Stanley, welcome back to class. And I think today, how about, Zach coded last time. I think, that's not, all right. How about Rebecca? You coded too recently, yeah? Spencer coded, Caden coded, Krishav coded. Yeah, Stanley, you could code if you want. Okay, so what we're going to be coding is a linked list. And if you don't want, that's fine. Yeah. And we have other, there are other people I want to nominate as well. So just let me know. Okay. So Stanley, is that okay with you? You want to code, or if not,
I'll watch this time. I'll watch.
You want to? Oh, you watch this time? Okay. All right. How about Ria also coded recently. Okay. All right. How about we just go with Eric? You want to code again? I know you didn't code recently. Vikram, you want to code?
Yeah, actually, I'm like kind of still unfamiliar with linked list, but I'm really happy to learn and try it out.
Great. Okay. All right. Okay. Fantastic. But you guys, you shouldn't, make me beg each and every single time. Okay. You should say, all right, be enthusiastic about it and say, hey, I want to code too. All right. Okay. Let me maximize the screen. And get more light. Boy, is there a maximum brightness for me? That's really funny. I thought, I thought I couldn't even tolerate a Mac at max brightness. Wait a sec. Maybe because there's a lot of black in the screen. All right. Anyway, get rid of the blue part and then and the white part, and then we'll just maximize Command A and delete, and then we'll just start with some comments.
Yeah.
Yeah. Oh, thank you. And get rid of the blue part and the white part also.
Wait, where's that?
The the less than sign on the blue, the left nav. On the left
okay.
nav, you see yeah, and then the white part, and yeah, I see. Okay, that's right. So and you can say class code for whatever today's date is. We're going to create and on the next line you can say we're going to create a linked list, which is basically a node pointing to more nodes. Yeah, as a class. Now this is essentially the same as your quest number 9, really, in many respects. So you'll be essentially it's like a walkthrough for quest number 9. But again, maybe what I will do this time also is I won't do all of it. I'll just say, well, this needs to get done, and then it's like maybe there's a push front or something like that, or push add, and something for this linked list that we the class that. Well, actually, no, we have to do some of it for the game. All right, we'll see how it goes. Okay. Oh, by the way, we didn't get a yeah. Hey, one sec. Okay. All right, hey, Vikram. All right. So, among the people who are here, who want to come in to class? If it's not, if we didn't get rained out, okay. If we get rained out, again, we'll just do everything on Zoom. If we don't get rained out, who would want to come to class in week 11? That's the last week we're allowed to have class. One more time, Thursday maybe, right? And then it'll be more like reflections. Maybe maybe there won't be so many people. I'll just buy pizza or something like that, okay? And you can just reflect in. And you can take notes for your final report saying, hey, I didn't know, thanks to Spencer, I didn't even know I said that and read it. Okay, now that goes in my final report. Yeah, okay, so you'll have a good opportunity to find out what you want to stress and, emphasize in your final report.
At what time of day?
It's a regular class, 6 p.m. And yeah, it'll be like this now. It's, pretty much dark now and cold. So yeah, okay. The thing is, we could technically have this on Zoom too. No, not a big deal. Okay, it'll be in Zoom, and just not, I won't be there. And it may actually be more convenient, really, to have it on Zoom. Why did I think we should do it in face to face in class? I didn't really know. I have a good reason, really. I don't have a good reason, especially if it's raining and it's cold. And I look in the window, out the window, it's not bright like summer anymore. So yeah, okay, I recognize that it may actually be better for you guys to do it from home. For me, because I thought, well, that's better for me. So all right, so maybe we can just do it on Zoom. All right, unless you guys say, hey, I actually do want to get together and and then we'll make it worth your while, and with a little bit of pizza too.
Professor?
Yeah.
I have 2 questions like unrelated to the class for next week. Is that okay if I ask right now?
Yeah, sure.
Okay, so first of all, when are we gonna get our final reports back and grades?
All right. Final grades will only be determined after your final exam. Yeah,
Okay.
that is answer part B of your question.
So are we allowed to know our grade like right now?
Oh, I don't know what your grade is. I mean, if you tank your final exam, your grade could change, right?
Yeah.
Yeah. So you
And-
should be able to calculate it from what you have right now, technically.
Okay. And also I think on like the very first week when we took our data representation quiz, you said you might open it in like the last week. Is that a possibility?
Yes, absolutely. Right. When you're ready, you can just let me know. Yeah.
Yeah.
And I'll reopen for data. Even for people that did really bad, Like, I mean, if you got more than 17, you shouldn't say, I want to do it one more time. But you got like 9 or 10, you can say, I want to do it one more time, and you can do it one more time.
All right.
Yeah,
thank
how
you.
about that? Hey, everybody,
Yeah.
you pass the message on. Hey, what was your first question, Vikram? That was the second part.
No, my first question was just about grades in the final report.
Yeah, final report should be done before your final exam, ideally. But it doesn't really matter, because I think when I put things into the spreadsheet, I will actually read it one more time. So it'll be anytime. Your best bet is to do it as soon as possible after the final exam, ideally before, so you can get it out of your head. Yeah.
Sounds good.
All right. Okay. All right. Great. And so and we want to do an experiment here. So yeah, so we'll say we want to create, so yeah, continue the comment. Say we want to create a special kind of show method for a linked list, which will show the contents with animation. Okay, so this is the bit that we want to try and have fun with. And so let's see if we can build up to it quickly. All right, okay, great. Now I'm going to talk through this code, not leave. In the past, what I did was, in the past class, in the previous class, what I did was, oh, here's what we want to do. And, and I said, all right, 20 minutes, you guys go ahead and code. But I'm thinking now I'll do some of this is going to be routine. So I'll just do this routine stuff. And when we get to the interesting part, I'll say, all right, you guys do it. Is that okay with you guys? Just raise your hand or do something, right? So I'll just do the regular thing that hey, fireworks. All right, okay. Oh yeah, and I figured this is the balloons. Yeah, okay. The funny thing is, I tried to do this in a college meeting. In college meeting, and I totally forgot what balloons were. I was trying all these crazy things, and they thought they were trying to ask a question, and I was muted, and so was so much confusion, and it was so much fun. And finally, I figured out. Just as I was checking out, I said, all right, that's a piece, and I got balloons. All right. Anyway, thanks to Juliana, strangely. All right, okay. All right, so for linked lists, so, yeah. All right, so this is what we want to do. So here's, and I'm going to talk through this like I did in the early parts of the code, where I was basically walking you through C++. So just bear with me. If you want me to go faster or slower, just leave it in your hands. Just let me know, and I'm happy to do that. Yeah. Okay. All right. So just say hash include IOStream and all that regular stuff. Yeah. 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 And I think yeah, in fact, yeah, right here we can start right there. Right there we can start. Yeah. So we can say class node, right? Class node. Yeah. Space curly brace. Yeah, thank you so much, Vikram. Right. And then it's an automatic 2-space indent or 4. Okay.
I think it's 2. Yeah.
I see. Okay.
Or maybe 4. Yeah.
All right. And you can say we'll just make an int payload. Okay. And we're going to say it's just public right now. But I want to make sure that you all understand that when you actually get the logic wired up, then you'll start looking at the security issues, and you'll actually look at the thing and say, hey, you know what, it has a payload, but it doesn't have to be public, so we make it private and make a getter for it. That is usually one way of doing it. Okay, some people say right from the word go, you got to flesh it out according to the rules, and say, all right, doesn't need to be, it's up to you. So I'm going to do it this way, but just in case you think that, well, you know what, this is not your style, that's perfectly fine. Okay. All right. So int payload, and then you're going to say node space star next. Okay, that is our basic linked list, and then it's all public, right? So Yeah, all right, let's do a constructor. Okay, put a, you know, next, yeah, enter. Yeah, let's do a constructor, node. And then, yeah, yeah, thank you, Vikram. All right, yeah, colon, right? And then you're going to say payload. Somehow, you know, did we do this before? Actually, no, let's do that other syntax. You know, I think so. We did this, and maybe Vikram, you had a question at the end of last class. Yeah.
Yeah.
No. Yeah. Let's do the other because that's good practice. You know, people, you know, it's good to do that the other way because this is a standard function way, right? So let's do it the other way. Get rid of the, you know, this thing, you know, the curly braces, or
Okay.
go after the parentheses. Yeah, go after the parentheses. All right, and then colon. This is the other way of doing the constructor, and it's, you know, just do it this way. For anytime you get an opportunity, do it this way. I think because no, just one colon. See, that's why when you get into the when you've done it like 4 or 5 times, you just know automatically it's colon. Right. No, all right, okay. So here you're going to initialize payload just like you initialize a constructor. So payload open parentheses data, right? Payload open parentheses data. Now what Vikram typed. Now and then what you're going to do is comma. No, comma, because you have one more parameter in one more member in the node class. Yeah, next. So you can say next, yeah, null pointer. No, why? This is what we did last class, I think. Yeah, I have this feeling.
Yeah. So do you want me to initialize it to null pointer or?
No, this is great. Yeah, this is great. Yeah, this looks great. Okay, and then we want to do this other method that I think that would be nice. What do we call it? Show animated list. Yeah, no, show animation, right? Just say show animation. Yeah, void on the next line, yeah, there you go. Yeah, thank you. All right, so that's great. So you automatically put a line after the constructor and going into this method, which is really cool. Because you know, for me, because it says that you have some kind of a mental structure now inside of the members of a class. What are, you know, what methods are getters and setters? They belong in a family, right? And yeah, and so on and so forth. And so initially what happens is most programmers will just clump everything together, and that's natural, right? But you know, as soon as things start getting messy, in the interest of time, really, and you know, and really, and that is why perseverance or doing things repeatedly matters, because if you do things repeatedly, then the mess starts bothering you. It's like, you know, if you live life long enough, then you find out what is annoying about life, and stay away from it. And so and the question is, and here essentially what happens is that after you put things together for a long time, you say, all right, I'm just going to clean it up a bit, right? So and that is how, you know, structure is born in essays and, you know, thoughts and public except in my classes, perhaps. Yeah. Okay. But I think, right. So it's a wild theory, but I think it is essentially just we're trying to make sense of these things, and some nice patterns make us remember things better, recall things better. Right. All right. Thank you so much. For if it was for that one extra line. All right. Okay. Show animation. And I think what we should do is, yeah. All right. Yeah. For now, we just say semicolon after that. All right, we haven't defined it yet. All right, okay. All right, so now let's do a main right here in this class. You know, you can get rid of the rest of these. No, not in this class. No, in this file, not in this class. Right. Yeah, and get rid of the main, you know, blank lines and all, and get rid of the blank lines. I know inside of your class. I don't think we need any of that at this point. All right. So I think what we want to do is create a node. So node, oh, actually, let's create a, let's create a node with the number 0. Okay, let's create a node with the number 0. Okay, so let's say node, so here, and it's, here's what we're trying to do. So we're going to create a node on the stack, meaning it is not out there allocated. Every other node than this is going to be allocated. Now, there is a way in which maybe it's extra credit to just change it so that every node is allocated, but we're deliberately doing it in a way in which the first node is on a stack, meaning it's a local variable, but inside of that is a node pointer. That's going to be an allocated node. And that guy's child is going to be an allocated node, and it keeps on going until null. Okay, so that is our list. Now, if you are comfortable with that, we'll do it that way, or maybe that will be an exercise, okay? Because it has two different things to it. We'll do it the easy way, okay? All right, so we're going to do it the easy way. Node star list equals, right? Equals new node. And then open parentheses. What's the constructor? Yeah, and then give it the value 0, right? All right. Now, all right. Now, list is basically just a pointer to a node, but inside of that is a pointer to another node, and it's currently null pointer. Yes. Now, how about 15 minutes? I think someone did this last class, and maybe that's why we should usually, I'm going to leave it in your hands. Okay, so we're going to stretch list out. Essentially what you're going to do is, after we added 0. Okay, so we're going to do a for loop. So hit enter one more time. Hit enter one more time, right? All right, do a for loop for size t I equals 0. How about we add yeah, let's add 100. Okay, let's add 100 nodes between 1 and 1,000. Okay, yeah, all right. So yeah, 100 nodes, and then you want to say oh, I see. No, yeah, list. I see. You know, go to line 22, hit enter. And then say node star p equals list. Maybe, you know, we could have done the list, thing, the structure differently, but, you can refactor it later. All right, that's all right. All right, okay, that's fine. Okay, and so you're going to say list arrow next equals, not list arrow next, p arrow next equals p arrow next equals. No, p arrow, p arrow, did you say p arrow next? And next, yeah? Yeah, p arrow next equals, what do you have there? All right, so a new node, and then let's say rand percent 1,000. Right, how many we're going to put in 100 nodes? Yeah, right. So we're just putting these magic numbers in, like 100 and 1,000. Not because this is not, we're not going after the structure and the cleanliness of the code right now. And there's no point in generalizing these things really. Then throw this program away at the end of this class. All right. Okay. All right. That's it. Oh no, there's one missing statement. All right. So hit enter. Hit enter. Hit enter. So someone should complete this, okay? So I shouldn't be doing the whole thing really. So someone should complete this. At the end of this, you should have yeah, whatever. Yeah, Spencer, don't use the chat, okay? You should talk to Vikram and tell him this is what you should do, right? So rand needs to be fixed or something like that. So you guys should complete this. How about 10 minutes of your time, right? 10 minutes of my time. I'm just gonna be silent, and I won't even watch what you guys are doing. But fix this code. At the end, list, not p, right? List should be a sequence of random numbers. Even though they're random, it should be the right order. Okay, so you can't just say I'm going to always insert at the front. Yeah, all right, insert at the front, because they're all random numbers. Because otherwise, if you keep on inserting at the end, it's either a quadratic operation in the length of the list or the number of items. Do you know what I mean by a quadratic operation? Because every time you got to go n and then n plus 1, so it's 1 plus 2 plus 3 plus 4 plus and so on and so forth. So the sum of the first n natural numbers is n times n plus 1 over 2. That's n squared plus 1 n over 2, right? It's quadratic in n. So it's like a parabola. So it grows, much faster than we can handle in most cases. So that is why inserting in the front always is you will keep things linear. If you have 100 items, it's just 100 times pushing it into this spot. That's it, right? Fixed cost. Like accountants, this fixed cost, we actually, love it because we can budget for these things much better. All right. Anyway, enough, rambling. So I'm going to leave it in your hands. Okay. So fix the code and then call me. And, fix the code audibly, meaning that, it shouldn't be like one person just typing and corresponding in chat. Take it as an opportunity to just open up and keep talking and calling out the code. Like Spencer said, rand needs to be fixed. You should be calling it out. Spencer?
Try P equals P next.
All right.
Could somebody explain like what a node is? Like I know what it is on the surface, but like a better explanation, I guess.
Wait, I couldn't catch what you were saying. Can you repeat that?
Like what exactly is a node?
Node is a class that has, and inside that class, it has some value, which in this case is the payload, and it also has a pointer to another node. So it's a self-referential data structure, which means it not only has values, which is the payload, but it also points to another node, which also has values. And then that node points to another node, which also has values, and so on and so on.
That kind of makes sense. Thank you.
Hey, are you guys there?
Yes.
Someone should keep talking. Otherwise, the suggestion I gave to Kaden was, as you're typing, just say, less than sign, greater than sign. As you're typing, just blindly say what you're typing. That itself is pretty cool.
What happens if you try and print the list now?
Okay. So, can anyone walk me through how we print this list?
Do a while loop. So
Right. Are you done with this part? I can, I can absolutely help. If you want me to, I can absolutely help with the next steps. Because I was just looking for the next bit to be completed, which I think is P equals P arrow next. Okay, that's great. That's great. All right. Now, the one thing that we need to do is we need to set the next of the very last cell, the very last node. We need to set the next to null pointer. Yeah. No, not
No.
inside the loop. Then it'll set it to the null pointer for
yeah.
everyone. Yeah. No, it's not next equals. It should be P arrow next. Yeah, P arrow next. No, P arrow next. P arrow next. Yeah. Should
Can you do that by
hey,
default?
Spencer, you should talk, okay? Don't type in the chat. Spencer.
he said he's in a loud environment.
Sorry?
He said he was in a loud environment, so I'm assuming he's not able to talk.
Oh, all right. Well, someone should, look at his question and speak on his behalf, because chat just comes and goes, and then you got to click, and then it takes up the screen. All right. Otherwise, we're just gonna move on. You can obviously, you should be able to simplify the code later, and when you share it, that is, in fact, if you
Yeah.
can make changes, even better, because you'll have a version that is different from here. Okay, all right. So now at this point, go to line number 30, get rid of that while loop, and let's start to put a comment there. It says at this point, list should be a chain of nodes starting at list arrow data. List arrow, what is it? Payload. List dot payload, is it? Oh no, list arrow payload. Yeah. Through to starting at list arrow payload, chain of nodes. 100, yeah, it's a chain of 100 nodes, I think. Yeah. Now let's not say 100, because then comments will be out of sync with the numbers, and just chain of nodes. Starting at list arrow payload, with list arrow payload. I don't know. I think that's all we want to say. Starting at list arrow payload. With the next pointer going to the next element of the list, right? Yeah, until the and the last pointer going to null pointer. I think that's what I wanted to say, and maybe I was. No, the next pointer going to the next element of the list, not the end of the list. The next pointer going to the next element, and the last pointer set to null pointer. Yeah, and the last next pointer, and the last next pointer set to null pointer. All right. So yeah. So that's basically it. Is that okay? All right. So now what we want to do is go to line 32, hit enter. Let's start yeah. All right. No. After that, yeah. One more enter. One more enter. Let's say first let's do a simple toString. Okay, with no animation. It's just going to print all of the numbers, dash, and then null. Okay, simple toString. Okay, so just start a comment saying first we'll try a very simple, toString, no frills. And you guys, 10 minutes for you to implement this. And this time, no silence at all, okay? Should be like buzzing with activity. Everybody should say, hey, try this, try this, try this. Yeah, because it's like 3 lines of code, 4 lines of code. You should be jumping over it and saying, I want a piece of 3 lines. Yeah. So you should do that. Okay, first we will try. So what we want to do is list. Oh, I see. All right. So we'll just do a global. So say print. Yeah, print underscore list. Print underscore list. Yeah. No. It's just a function. Just say print underscore list. Print underscore list. That no, it's a function call. No, you can get rid of the comment. Yeah. Print underscore list. Open parentheses, and then the first parameter is just going to be the list. Yeah. All right. Okay. And it's a void. And in fact, no, not star. No, hang on. I think I confused you too much by, get rid of the word void. Get rid of the word void. Right. And print list takes a parameter. Okay. And the parameter is going to be that word list, because we have a list, and that is our node. Yeah. That is our first node. Yes or no? In fact, if the majority of you are in agreement, instead of list, just rename it and call it first node. Okay, if that makes more sense. Now put a comment. Put a comment above on line 19. Go to line 20, hit enter. Yeah. All right. Yeah. Say if you're more comfortable, call it first node, first underscore node instead of list. Right. Okay, maybe some people would actually like that, because then it maps into there's not 2 things. There's only one thing here. Okay. Right. All right. So print list and then return 0. Now this print list function, semicolon at the end, and then return 0. No, you got the return 0 already. Get rid of the blank lines. let's define the function. Let's define the function print list, okay? Above main, go to above main, line 19, and do a void. Yeah, who's coding? By the way, I keep forgetting who's coding. Vikram, you're coding.
Yeah.
Yeah. All right. A void print list, okay? Open parentheses, and then you're going to say node star first node. All right, node star first. Right? And then curly brace, and then close curly brace, and then inside you're going to be to the to do. You're going to do this, but in the comment on line 19, go to line 19 and hit enter. Right? Yeah. And this is going to be a to do for you guys. And I think it'll be a juicy little tidbit for about 10 or 15 minutes. Okay. You can actually try it out on your own, maybe, right? And say, hey, here's Jonah's version or Rebecca's version. All of these things are really cool. You can try. Okay. So to do, that's not where the to do should go. Right. So there you just say this function will print out the list. And don't say to do, right? Get the to do out of there, because this function will print out the list beginning at first node, right? Until the end, which is null pointer. Within parentheses, you can say null pointer, right? And then after the parentheses, you're going to say space and use a hyphen between two values, right? A hyphen between every two values. Yeah. So instead of so you look, and then the word null at the null at the very end, and use and the word null at the very end. Yeah. All right. So this, I think, is a nice little challenge for you. Yeah, like 5 or 10 minutes. Is that okay? Just give me a thumbs up or something, because especially since the camera is off and I can't even see a thumbs up and all. Right? 1, 2, only 2 people. Yeah. Caesar. Yeah. All right. Good. Hey, Ben, you're good too. Raj, Kira, Rebecca, Kaden, Stanley, Ria, Jonah. Also it's like a roll call for me. It's just making sure who are you, which ones are here. Brian, are you here? Brian, where's he gone now? He's gone. Oh, Brian, are you here? Okay, Angelos. Yeah, hands are all disappearing. Oh, because it's the thumbs up and it's not the thumbs up will keep on disappearing. I think we had the same problem last time. Because the raised hand stays raised until you lower it. Thumbs up will disappear. Oh, some of you are getting 2. Don't worry about it. It seems like all of you are okay. Well, actually, I don't remember. Rebecca and Kira. Kira, are you good? You good? Isidore? I don't actually remember. Things are also shuffling on screen, so it's hard for me to keep track. Which is kind of funny. There is an option in Zoom. I need to investigate further. Just freeze the order. Don't keep shuffling. I think that'll be much easier for me. All right. Okay. So I'm just going to go and drink some water, come back in like 5 minutes or so. All right. Just call me. I'm just going to be within earshot here, and let me know. Thank you all. Hey, the hands up. I think you can lower your hands now. Yeah, unless if you actually have a question or something. Great. Thank you all. Okay. So this bit you got to do. And if you're not able to, if you get stuck and all, I can come back and do it. Chris can also complete. Where's Chris? Is Chris here? Chris, are you here?
Yes, I'm here.
All right, okay. Chris can also do it. I'm sure, a whole bunch of you can do it, right? Because I know from your questing that you're actually, doing these things. So I'm actually confident that you can do it. But if you do want me to, I can sit down and dictate the code for this too. And all it has to do is number hyphen null pointer. That's all. Okay, given. And then if you're given null, you just say null pointer. That's it, right? And you should just be able to do it in a for loop or a while loop or something like that. And this is our first step. After this, we'll see if we can animate this using sleep and all. That's the fun part of this class. And considering it's the last class of this week, next week we'll have a class on Zoom on Tuesday. If it, we'll see, we'll decide. Okay. Yeah, did we decide? Do we want Zoom here, or do we decide about Thursday on Tuesday? Yeah, you can all send me email maybe and say, hey, I'd prefer to have class on Zoom on Thursday too, because it's just a reflection, it's a group reflection. right? No class really. You're just going to get together and say, hey, you know what? Okay, give me some help. You know, what did I do? You know what? You know, let's talk about stuff that happened in different weeks so that you can take notes and say, this is what needs to go in my final report. So that'll be the Thursday class. If you want, we can do it in class. If we don't get rained out, I'll be happy to be there, and hopefully we'll have, you know, hopefully we'll have someone able to deliver pizzas at Foothill campus at that night. I've had it before. I'm pretty sure in the PSEC building, so I'm pretty sure they must deliver here too. So we'll see. All right. So if I'm there, I'll do that. Otherwise, if it rains, we'll just do the whole thing on. But you got to tell me. Let me know by email or some kind of message or something like that over Canvas or over the next couple of days. Okay, before Tuesday, and then we'll say Tuesday will be on Zoom. Again, we'll do Thursday like this, and that's it. You know, I'll also answer questions you have about the final then. And hopefully we'll have the game done by then, okay? If we don't have the game done by then, we'll, you know, very be so close that on Thursday we can, you know, next Tuesday we could just meet to play this game and have any further questions you have about the final that can also be answered. Yeah. Also, any doubts about any topic we've covered from day one, okay, starting from data representation all the way through to pointers, manipulating these things. That'd be cool. All right. So if we manage to complete this, where I'm planning to go today with this is after we do this, we'll do a little animation where we want to say, all right, now show this list with animation. All it's going to do is show all of the list. Well, again, 50 elements, as much as will fit in one line. You say 50, right? And then dot, maybe, I don't know. And then wait for 0.1 second. I don't know, some configurable time. After that, you're going to do a /R, go to the beginning of the line, okay? Use Isidore's trick, right? And set W all the time to 100 columns or 50, whatever the width is, so that you already, you know, even if you're printing 50 numbers, it'll space pad it automatically for you. Right? If you're in doubt about any of this, ask me, or Isidore hopefully is here, okay? And he can walk you through this too. But what we want to do is print out the list, okay? After 0.1 seconds, you're going to rewind with a /R, not with fancy ANSI positioning and all, just /R. But remember, after printing, you got to do a cout.flush, or, you know, send the flush character that Ben did. Yeah, otherwise it won't appear. So you're going to send that string, no endl, okay? Don't do an endl. Print it, flush it, wait for 0.1 seconds, right? Go back to the /R beginning, right? Now print the same kind of thing, except starting with the next element. Now, the visually, in my mind anyway, it'll look as though that list has now shifted. Okay, now, you got to arrange the you know, look of it in such a way that the hyphen also moves, right? Because otherwise it'll look like the hyphens are all in a fixed place and then numbers are just shuffling around. That doesn't look so nice. So what you have to do is you have to break up the animation, but you get the basic thing okay, and then you can fine tweak, you know, tweak the animation, get everything looking nice. Okay. So when you say show me the list with animation, it's just going to show you a portion of the list. Okay. And then you're going to have an animation 0.1 second. Okay. As the list is basically riffling through you, right? On /R basically. And it's moving from right to left like this, okay? And maybe a null pointer at the end eventually coming, right? Like a bogey, right? And when the null pointer hits it, you say you're done with the animation, okay? That's a challenge for you. Now, when we get that done, I was hoping, right? If this is a challenge level, and maybe it's an extension of the puzzle game and things like that you guys are doing, okay? Yes. And this is really for, you know, extra credit, really, because we're talking about algorithms that are maybe involve a little bit of mathematics. Okay, so it's really optional for you. Now imagine that all along we're actually dealing with lists, meaning element, the last guy is a null pointer. So we know that's a linked you know, list of elements, and the last guy is a null pointer. Yes. Okay. Well, in CS2B, we'll encounter certain data structures in which, you know, you have two branches. Now, that's okay. We'll you know, handle that later. Now, here is a challenge for us. imagine that instead of the null pointer at the end, okay, we don't have a list, but it's actually a ring. Okay, so it goes element, 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 but the last guy cycles around, and instead of a null pointer, points to the first guy. So if you were to find yourself in the ring, okay, you can always say, oh, I'm going to go to the next guy, next guy, next guy, next guy, next guy, okay? But you'll never find the end, because you'll never find a null pointer. You'll keep on going in an infinite circle. Yes or no? All right, Angelos is the only one who said yes. All right, some of you are. Okay, okay, anyway, all right, so I'm saying that you can build this into a game, okay, with the 0.1 second wait. If we get to it, I can walk you through this too. What you'll have is essentially a list that has been manufactured, 100 elements behind the scenes, 100 elements. Let's just keep it realistic. 100 elements behind the scenes with random numbers only between 0 and 100. Okay, so there could be some repetitions. That's fine. In fact, more the repetitions, better, maybe, right? Or maybe you got to play with the numbers. Okay, so however, you don't know. You're going to toss a coin. 50% probability. Whether this is the pointer you get back, you don't know whether it's a pointer to a list or to a ring, which is also a list for all practice. You don't know, right? Because you could go to the last, and the last node could be pointing here. You don't know. And that when the list was manufactured by your function, the guy that made the list flipped a coin on the last node and said, okay, that's a null pointer, or it's going to the first node. That's all. Okay, and you don't know from that point onwards. Okay, now your challenge is to figure out whether it's a list or a ring. Okay, well, that's an extra credit challenge of one kind. Okay, but that's not the game, right? The game is you get this pointer, okay, and then you're going to use this animation technique, and then in the animation throw in a /A. Okay, /A is a bell character on a keyboard. Okay, so instead of just a list animating, you'll actually hear these noises on your keyboard. Okay, primitive noises like click, 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 but it looked like something is moving and clicking at the same time. So it may actually be fun. So /A in the thing will actually create noise. So all right, okay, so in what you're going to do is, given a pointer, you're going to say, here is the animation of the pointer, and you're going to animate it for I don't know, 1 second, not with a 0.1 second each time, but with a steadily increasing duration, so that it appears to slow down. And you're going to stop after it slows down a certain limit. Okay, we actually did this in a previous class, I'm pretty sure. Okay, maybe some quarters ago. If you ask me, you can give it a go yourself. If you want to do it together in class, I'm happy to do a Zoom like this and walk you through that. Maybe it's one class, and it'll be fun. What we're hoping to happen is that you get given the list with the animation of the list. It's like a wheel of fortune. Yeah, it's like a wheel of fortune. Okay, so the list is presented, and it shuffles to the right, and then it slows down. It doesn't go all the way to the end. It slows down and stops. Okay, and maybe you get to do that 3 or 4 times, but you got to do that within 5 seconds. So that's your challenge. So if you manage to do that within 5 seconds, maybe you have some luck in looking at a pattern and saying, hey, that's a ring and that is not a list. Okay, so you have better than 50% odds in finding out whether it's a ring or a linked list. Okay, and if you're good enough, you can actually find out, scroll, okay, it's a ring. Okay, then you say, well, I only took 4 seconds. That's a ring, not a list. Okay, and then you can check from the background. Okay, maybe the Boolean return tells you whether it's a ring or no. This is actually a fun little project, and it'll actually be fun even in a on an iPhone or things like that, where the animation is smoother. But we'll try and make the animation as smooth as possible, because with a long list and the sound and the bars moving alongside, it'll actually look fun too. Right, so I think it'll make for a nice extra credit project. But things like Isidore and Ben, all the other people have been experimenting with. Related to what we're doing, it's super duper fun and great experience at the same time, and scope for expansion. So this will be a nice game. Okay, and this is a nice game once you get the logic right, and then you want to develop an iPhone version of it. where you say, I want to, this is an app. You want to try that 5 times every day to make sure that you're, cognitively, staying in step or things like that. Okay. Every day in the morning, you get like 5 lists and you have to scroll. And in 5 seconds, you got to tell whether it's a ring or a list. Okay. And you get 5 of those right. You say, all right, you're good for the day. All right. So I can see that becoming addiction, like toothbrushing, brushing your teeth. Get up in the morning. I got to do 5 of these, right? Just to make sure I'm good. Right. 5 very simple algebra problems. And those kinds of things on a phone or a device like that could actually be very, not addictive, but things like toothpaste, where you actually just get accustomed to a ritual and saying that actually makes me feel good about the start of the day because I've solved some problems to start with. Yeah. So I can show you how to do that. But the logic should be ready already before you get to the UI part of it. Because the UI part of it, when you go to Unreal or to iPhone or Visual, or what is that? Vision OS or whatever the Apple thing is, right? Whatever, Oculus or whatever it is. That is the look and feel and the skin. You can skin things differently, but the logic should be the same. So the logic should be worked out and the logic should be ready in code separate from that. And in fact, the logic is so simple, we can actually do that just in online GDB, and I can walk you through these kind of things. Essentially, get it to a place where at this point you can say, I'm going to take it to VS Code or Xcode and, build something on top of that. I'm happy to work with you, especially, since the holidays are coming up. So I think I'll have a bit more time for those things. If you're interested, okay, I think this will be fun and a great experience for you too. Right. So this is basically it. Do you guys want to do this? Right. Print list is the first thing that we're going for. There's no animation. It just needs to print all of the numbers with a hyphen between the numbers and null pointer at the end. Is that okay? So if there's 100 things, it'll maybe wrap around a few times. Yeah. Okay. So the animation will take care of all those other things. Right. So in the next thing that we're going to write, is that okay? I can turn the laptop around so I'm not in your face. But you should be talking, because if you're not talking, I'll come back and say, hey, are you guys here? Or are you checked out? Okay. Then I have to start talking again. So if you're talking, then I know that you guys are active. That means I can, take off, not take off, not be in your face.
All right. So for print list, we're probably gonna have to have a for loop to print all the values.
We could also do a while loop that
Yeah.
checks if the node is null for its condition.
Yeah, and then once it becomes null, maybe after that we can add null to the string.
Yeah.
So first we want to define a string, right?
It is printless, so we could just use cout.
Wait, what do you mean by that?
Like, we could push everything that we would add to the string to the cout, and then we wouldn't need a string variable.
All right.
Wouldn't it be better to use a string stream?
Wait, I couldn't hear that. Can you repeat?
Wouldn't it be better to use a string stream?
Oh, so stream?
Other people have better ways of doing this. They should just, say, all right, do it this way. Right? And because if there's, uncertainty and someone knows this is the way this should be done, they should just take over and say, this part I'll drive. So that way many people can drive and then it'll all come to a fruition.
All right. So for the person who said, let's do the cout instead. So I'm just gonna delete the variable. I'm gonna go with my while loop. So is it while or
I believe if you just do while next, it will check if it is null or not.
oh, okay. And then after
Well, but first you need a next like pointer variable before the while loop.
Wait.
It
Isn't
would
next already part of the node class? It's like it's part of the node class, so I don't think
Oh,
you need to
well,
define next.
then you would do, you need a pointer to whatever the current node is.
Right.
um,
So node pointer equals. We set that equal to first.
Yeah. And then it would be pointer arrow next instead of just next.
All right. So while that is true, we will see out, right?
Yeah.
I don't think with that while loop, I don't think you're going to be able to print the last value because for the second to last value in the linked list, or for the last value in the linked list, it's not going to have a next pointer, but it's still going to have some value that we want to point at. So I think it should be while pointer and not while pointer next.
Isn't the last value null? So then we just put null after this
Is
while
that
loop.
how it's implemented? Why is the last node null?
I mean, the linked list keeps going on till the element is null, and that's the last element. Correct me if I'm wrong.
Pointer.
That is correct.
Okay.
I might be wrong.
So I think that if you're on the last element with content, its next pointer will point to null, and therefore it will not print out the content from that last node before the null one.
Yeah. Oh,
So that would mean you should either change it to a do while loop or remove the next.
okay. I'm just gonna remove the next to keep it less convoluted. So we're gonna have to print out PTR arrow next.
I believe it would be PTR arrow payload because we're printing out the data.
Oh, wait, are we printing out the data? Okay, it's values, right? Okay, so PTR arrow payload, and then hyphen.
Why is there an empty string between the cout and the pointer payload?
I thought we are supposed to like define a string before we attach the PTR
Oh, so
payload.
we just don't know what goes in there.
I mean, that's what I usually do. We need it? Because that's what I usually do. I don't know.
I don't think it's necessary.
All right, I'll delete it for now. So after we're gonna have to do and then we're gonna have to do end lines, right? Or no, we don't, because it's hyphens.
I think you should add a flush to the end of that just to make sure it actually prints.
What does flush do?
Means the buffer, I believe.
So it might not print if you don't have flush or endl at the end because it's trying to optimize itself, but it will definitely print if you do a flush, and you might have to say std : flush.
All right. I'm honestly familiar with end line, so I'm just gonna do that. but I understand.
And you'd also want an end line after the null.
Okay. Okay. Is that it? Does anyone have any other ideas? I think we've completed the task.
I don't want to do STD : and L for both.
All right.
Also, one thing, I don't really know why we declared another node pointer, like pointer. I think we could have just used
Oh,
first
yeah.
the entire time.
That's
It's a small change, but
no, I
Just
understand
something.
what you're saying. It's just save lines of code, right?
Mhm.
So while that's not pointing to a null, we're printing out each
Uh,
value, splitting it by
No, you're printing out pointer payload. It needs to be first payload.
This is correct, right?
So you changed.
Oh, this is gonna be first.
Yeah, and then you also have to make sure it first points to the next thing in the list,
Okay.
which might be kind of confusing.
No, I understand what you mean. Because we have to
you
keep going down the list. Is that where you're trying?
You have to do first equals
First equals first on it first, yeah.
Yeah. There you go. I think that should work.
With
Great,
passing in
great. That looks good to me. Hey, by the way, I thought you were using namespace and it has a main and all, right? So you don't need the STD.
Oh, I don't need the STDD, right? Okay.
Yeah. You would need, by the way, you would need that if this was, a function out there in a header file and, but because it's a main and it's experimental, we have this up there. So that's why you don't need it. And you had one more of those too. You had one more of those.
All right, thank you.
And okay, that looks good. Okay, and each element while first. Okay, now one was, and it's perfectly fine. This is great. Okay, one suggestion I might make is that print list. The funny thing is, because the variable name is first, it doesn't matter in the least to the compiler to anything at all, really, because the variable is called first. The parameter is called first. I feel queasy about reassigning it to the second or the third or anything else. So what I would suggest is it actually makes no difference at all from a compiler's point of view, because all you're going to do is on the next line, node star p equals first. Thank you. All right. So that way also it's kind of more sterile. I think it's a programmatically sterile, meaning that even though it's right, it's on the right side of things, more on the right side of things. Okay, so you take your own copy, even though it's not marked const, so I think it's more like defensive driving or defensive programming, where, all right, the caller didn't care whether it was const or not, but really I shouldn't be messing with it, so I'll treat it like a const. And so that's what we're trying to do here too.
Professor?
Okay. Yeah.
Just a real quick question. I came across const a lot of times, like in method signatures. Can you go over that real quick?
Yeah, sure. Which one do you want?
So just explain the term. Yeah, const.
Yeah, sure. Okay. So const is basically is just a keyword that you stick in front of parameters, usually parameters. It can go in other places too, and as we'll know, right? And in fact, that is a great discussion point in the Reddit forums. What are the different places where you can use const? You can use const after a function declaration, after a function, right? Or it can go before a function, or it can go, in front of parameters. So there are different contexts in which it can go, and this is what it all means. Okay, maybe it's just one short write-up, but it's a fantastic write-up. Okay, and maybe it'll even get cited in Stack Overflow or other places saying, well, I didn't know there were so many different contexts in which const, the word const. Right. So the most common way where you would see it is in front of parameters. Okay, what it means is that I'm giving you a parameter and I'm passing a parameter by reference. That's important, right? C++ lets you pass something by reference, yes?
Yeah.
Original. So I'm passing you an entire movie by reference because, I don't want to copy 5 gigabytes. So here, the 5 gigabytes are stored in RAM, and this is the movie object that contains 5 gigabytes. I'm passing you, and it's there in memory, I'm telling you OX4764 because that's where it's stored. Then I'm passing you a reference to the actual movie. Yeah.
Yeah.
All right. Now, if I want to do that, I need to trust that party 100%. Otherwise, I can give them the original and say, don't touch it. Yes or no?
Yes.
All right. Okay. If I want to do that, if I want to give it only to people that I trust 100%, that severely limits the number of people that can use the function that I wrote. Yes?
Yeah, that makes sense.
Okay. All right. So, we have this really nice, cool feature called const. That's anyone can use it, but you won't be able to make any changes because it's const. So when I declare that parameter, I'll say I'm going to give it to you by reference. Yeah, or you give it to me by reference, but it's marked const, meaning I can't change it, or you can't change it when I have the word const there. That's what it means when it goes in front of a parameter. Yeah.
So you can change. Wait. I'm a little
when I say a parameter is a const parameter, yeah.
Yeah.
Most of the time, I mean it's a const reference, meaning it is a reference parameter. Original is somewhere else.
Yeah.
And it's been marked const, meaning, the compiler will say, have the library designers back and say, anyone tries to make changes to it, it won't let them.
Okay. All right.
Yeah, because it's been marked const. And
All
if
right,
you try
yeah.
and change a const parameter in your function, it'll basically say, hey, you can't change it because it's const in the class. Yeah.
Okay. So that's set. It's a set value.
Yeah.
All
So,
right.
and that's what I mean. All of you, for anyone, not just Vikram, this is a fantastic opportunity to find out the five different, right? Let's not say all the different ways, right? Let's say 5 different contexts in which the word const can be used. I just described one. The other one is when the word const goes after a method name in the class declaration, right? So you could say toString const, right? Void or, void toString, open parenthesis, close parenthesis, and the word const at the end. Yeah.
All right. That was
All right.
helpful. Thank you so much.
That was also, that's also a possibility. I'm not going to go into what that is. Okay. So you have to do some research and find out, all right, that's one way, right? So there's another place where you can use const, and inside of your functions, you can say, hey, this integer, int number of rounds in this game is 47, right? And you say it's const, nobody can change that. So that's another context where const can be used. Yes. All right, it looks like you're coding. This is your mouse moving and nobody's talking.
Oh, sorry.
Right. So
Sorry.
anyway,
I was
there's
muted.
extra credit in this. Okay. Anybody, not just Vikram, anybody, just discover, not like, ChatGPT style, just discover all the different ways in which you can use const. And they're different, even if you're an experienced programmer, it's just, it's fun to see them all grouped together sometimes. We just overlook this sometimes. And so just get together all the different contexts in which const, and make a little chart or a graphic or something like that, and just share it. And it'll be fun. Okay, and it's definitely worth extra credit, these kinds of things. And also sharpen your understanding of what's actually really, sets C++ apart from many other languages, because the logic is exactly the same that you learn in many other languages. I think the difference between C++ and some of the other things that we teach, like Python and Java, is in the amount of discipline required. That's the only thing, because the logic and the solutions and everything is the same, exactly the same. If you think about it, right? Because we solve the same kinds of problems in 1C and 2C. And, graphs and, all these algorithms. But I think the C++ track, in addition, has this requirement that you also develop a certain degree of discipline, right? So discipline meaning it's a programmatic kind of discipline, right? Even if you're not a C++ programmer, that's what it means, right? So even if you're not a C++ programmer, if you're a Python programmer with a C++ kind of discipline is hard to find. And what that means is just having in your mind, a really clear picture of what the resources are and how much you're using each, right? And that only comes with practice. So you got to find as many different ways of injecting yourself into situations where, coding and solving these problems is required of you, because otherwise if you're not conscious about it, if you're not majoring in computer science, right? If you're doing something else, that's okay. I'm majoring in computer science. And if you're not deliberate about this, it's like music practice, it just slip away. And after a while, you'll find you're out of touch. But you got to find situations like, take part in these, hackathons or foothill at the CS club. Doesn't matter. Give it a shot, give it, or, go to Leak Code and solve these problems. But every single day, you have to keep doing this. And maybe after, I don't know, a few months even, you just feel completely differently about this whole thing. Yeah. But you got to give it a chance. Most people say, I don't, get a chance, but they don't give it a chance to, you have to give it a chance. And most people are impatient, I think, right? Especially youngsters, because there's so many things out there around you that all require short attention spans and instant gratification, that this seems like a distant fruit at best. When I say you got to slog at it for 3 months before you see any tangible benefit, and everybody else says, I got this really cool video, you got it for 10 seconds, you get some gratification or something, rush out of this. Right. And it's and so it is up to the student really to eventually get tired of these things and say, all right, now where's the real stuff here? And you can go for these things, but you got to keep on practicing this again and again, different kinds of ways. So we'll do this today, and then we'll do the animation. That's again practice. Okay, animation, previous skills plus this and a little bit more, and then we'll do the game. Okay, and if interested, we'll continue this game on Tuesday also and finish it. Now, is this okay? Is that all that's done? All right, yeah, that's it. Okay, you are in the process of calling me back. That's great. Thank you all so much. Okay, print list. Now, do you want to test this? Do you want to test this, or all right, let's go and test it. So go to your main, and then just call print list. Oh, you actually did call it. And you have an endl at the end. You should be able to run it, and you should be able to see 100 numbers with a dash, right? Yeah, hit run. Oh, you're doing an endl after each line. Where's your for loop? Oh yeah, no. Get rid of the endl. Get rid of the endl after each line.
Yeah.
Yeah. No. That you need the endl there. Yeah.
Oh, the null. Okay.
Because you won't need the endl at the very end. All right. Yeah. Great.
Why do you need the endl at the very end? Why do you need the
because
endl
if you
at
don't
the
put
very
the
end?
endl, who asked that, by the way? Liam, was that you?
And
Ben. So you said why you use the endl at the end?
Why do we need the endl here?
Well, if you don't use the endl, you have to flush it, I think, because otherwise there is no explicit flush. Why would you not use the endl at the end?
I'm just curious. I just wouldn't have if I had programmed it myself, but I'm just curious if there's a good reason to.
No, I think you can go either way with this. This is just an experimental function. You're going to toss it at the end of the day. You just want to make it as easy as possible. But what you can do is not even do a print list. You can just do a toString, which returns a string, right? Which doesn't have the endl, and then the caller has the option of adding the endl before printing it. Yeah. So I think that would be the better way to do it. You're right. But we're calling cout and all in an interior function. And so already we're like on the other side of the fence. So yes, good question. Yeah, endl seems like you are right. It actually does look like out of place in that function, right? Because everything else seems safe, and this guy seems from outside. But cout seems from outside too. Actually, we don't. You don't see that. Yes, Ben.
You don't see cout. Sorry, what was that?
Yeah, but this is also cout. Yeah, we shouldn't be using cout either.
What should we be using?
In that function? Yeah. But we call it, print list. And anyway, we shouldn't, belabor this pedantic discussion between me and Ben. So we can carry on that thing later if we want. Okay, that's good. Okay, now here's what we're going to try. Okay, so let's create this void. Void show animated list, and then a node star first. Okay, I think so. We'll give it a shot and see if it goes. Okay, node star first. Yeah, all right. Curly brace. Yeah, all right. Okay, now this is a function we're going to write. And then in our class we had a function called show animator or something like that. Get rid of that function. Let's do global functions at this point. Yeah. Yeah. All right. Actually, this is a lot better in terms of understanding what a linked list is, really, isn't it? Because a linked list is basically a structure with a pointer to another of the same kind. So we just whittle it all the way down to this, right? We got a node which points to another node, and everything else we do with it's basically a global function, right? So what this needs to do is, did we have comments out there? Oh, no, we didn't. So we can put the comments there. All right, okay. All right, so yeah, there you go. Thank you. Right. So here is the planned animation. Here is the animation. Right. We print up to I don't know, up to 10 elements of the list, up to 10 elements of the list. And then wait for 0.1 seconds. Yeah. No space after the, before the S, right? Wait for 0.1 S. Yeah, no, don't put a space there, because the S will just be on its own then after that. All right, okay. Wait for 0.1 S. And then do this and then repeat. Yeah, and then repeat from the next element on until and repeat from the next element here's what we'll do. Okay, here's what we'll do. Now I want to see how we can state this in a comment nicely, right? Hey, who's coding, by the way? Vikram, are you still coding, Vikram?
Yeah.
All right, okay, thank you. I forgot. Anytime anybody else should just say, I want to, take over, and that's fine. You can just fork it and take it over, right? You don't have to start from scratch every single time. Just fork it and take it over. And I'm pretty sure Vikram will be happy to do that too, I think. All right, okay. So can you just let's just redo the comment. I think I'll state it much nicer, and then it'll be clearer, right? What we do. Here's the animation. We want to show the list. What marquee rolling to the left with gradually decreasing speed and stopping when it's slow enough. Okay, all right. I think that's that's what we should do. We're trying to write the program, use pseudocode up there, and that's not what we wanted to try and do. Now, does it make sense? So what we want to do is essentially do that print list thing that you had already up there. So we're going to do that with a /r, go to the end, and then after 0.1 seconds, let's say 0.1, right? It's going to change. It's a variable now, right? So after that many seconds, it's going to go to the next node and repeat the same thing. Okay, so in other words, the list would, but we're not going to do the whole list now. We're only going to do 10 elements and then ... Okay, so it'll look like the list is actually shifting into place from outside. However, we'll introduce a visual effect and say it's going to get slower and slower each time, right? Each time it moves, it's going to get slower, just like a roulette wheel. It has retardation, and we'll just do linear maybe right now, or something like that. Well, let's say the time to wait between the moves is it starts with 0.1 seconds, and slowly it goes to up to increases up to 0.5 seconds, and when it hits 1 second, it stops. So 0.1, if you double it, no, you can't double it. Let's say you go times 1.1. Okay, yeah, all right, okay. So what we're going to do, here's what I'm thinking. Okay, so we'll show the frame, wait for some certain number of seconds, let's say 0.1 seconds. Okay, next what we're going to do is shift by one element, and then show the next section of the list. However, we're going to wait from the previous wait time times 1.1. Okay, so whether it was a 0.1, it's going to wait for slightly longer now. So each time we wait slightly longer, which means it gets slower and slower. Okay, and then eventually it's going to get bigger than half a second or 1 second. And when it gets to 1 second, you say that's the end of the animation, right? So at that time, you may not have covered the end of the list, right? If you're lucky, you would have got to the end of the list. But we'll figure it out. I think the important thing is to get the animation right first. Okay, so let's play with that first. Well, basically, we'll just generate juice as we go along, so that let's not just save it up all the way to the end and say, all right, getting the animation is enough of a fun thing right now to keep us going, right? It's to build the next stage and so on and so forth. And that way, we'll have fun all along, right? And I think it'll be much better. All right, so is that okay? All right, so here's what we want to do. Inside of, yeah, and then let's do the usual thing, node star P equals first, node star P equals first. All right. So here's what we want to do. All right, so say float slowdown factor equals 1.1. Okay, so we can tweak this in the end. I mean 1.1. Slowdown factor equals 1.1. Okay, all right. Now let's enter. And here, what we want to do is yeah, let's say oh no, hang on one sec, okay? Yeah, float. Oh yeah, after slowdown factor equals 1.1, comma, yeah, one more variable, okay? A delay equals delay between frames equals 0.1, right? Delay between frames. Oh yeah, delay equals 0.1. Yeah, that's fine. Enter, right? Now you can say while delay open, yeah, delay is less than 1. Yeah, let's say 1, less than 1, less than 1.0. Yeah, meaning that your wheel starts getting slower and slower, but the moment it gets so slow that it takes 1 whole second to shift to the next position, you say that's the end of the animation. Does that sound reasonable? You can change these numbers later on. Maybe you can say half a second later on, but you'll start with 1.0. All right, okay.
Did you want delay to be less than slowdown factor or 1?
No. Slowdown factor, what's going to happen is that every time you do that string print, you're going to wait for delay seconds. And then after you wait for delay seconds, the next delay is going to be the previous delay times slowdown factor, meaning the delay equals delay times slowdown factor. So each time delay gets longer and longer. Does that make sense?
Yeah.
And then eventually when delay is greater than 1.0, it's going to say I'm done. Is it greater than or equal to 1.0? It's going to say it's done, and then you say return 0. Right? You say return at the end of the while loop, right? So now, if you guys, how about get rid of line 43 and 44? You don't even need a return because it's a void function. All right. So now I think there's a couple of lines here in line 41. A couple of lines maybe. What you need to do is print 10 elements, and then if there are more than 10 elements, you need to print ... Yeah, and then flush. Don't forget the flush, the flush thing that Ben pointed out in a previous thing, right? So you're going to print the flush. Otherwise, with the /r, it's not going to show. So you're going to do that. And then wait for delay and then rewind, right? And then also you're going to use Isidor's idea with set width to make sure that every line is like 80. So that, you don't, if the null keeps moving this side, you don't leave trash behind on the previous line, yeah? So you're going to say every line is 100 width, okay, with set width and IO manip, right? And it's going to print the list with the dashes, and then you can get the animation right to say, all right, I just don't want to just move the numbers. I want to move the dash with the numbers, and all you can get fancy with that. Okay, so let's do that basic thing first. It's like 2 or 3 lines of code. Would you like to do this, right? Give me a hands up, or raise your hand, or thumbs up, or something like that. If you want to do this on your own, it's like 2 or 3 lines of code. Would you do that? Because after this, we can actually run it and see the animation, right? Once we have the animation, is one more step, right? We'll just make this rest of the game. Say we're going to manufacture this mysterious ring of 100 elements. We don't know if it's a ring or is a list. Okay, and the only thing you have is that you're given a visualization and animation in which you can, scroll it 5 times to the left, but you got to do it within, I don't know, a certain number of seconds or whatever it is, and you got to make a decision whether it's a ring or a list. And so I'm pretty sure you can get a better than 50% chance, right, of doing that. And you can have the same kind of game thing that you build up, and say, all right, did you get that ring, a ring or a list? Get it right like 5 times in a row, all right? And that's great. And you move on to the next level and say larger rings, and you can make these things more and more interesting and challenging. Yeah, everything you want to do, essentially, once you've done something interesting and you say, all right, now I can take it in many different directions. There's so many different ideas that you can basically try and exploit. Okay, without having to use any of the fancy new tools that are coming out, because that's always out there. At the end of the day, all these standard programming things, most people don't actually need to know to get something done. At the end, eventually, right, in a few years from now, we'll have systems that write good quality, efficient code too. But why is it still important to do these things, right? It's not because of some utilitarian reason, right? Because we want to do it just like art and say, hey, that's an interesting way of looking at things. It doesn't matter if 100 people have solved the same problem before. We're still solving it. Yes. Why are we doing it? Why are we learning a certain algorithm, even though this particular thing has been studied endlessly in all the civilizations known to man? Yeah, it's because there is this thing, that's intrinsic value in these things that's never going to go away. And that's why it's important to do these things rather than, I think, saying, well, you know what, I have the necessary things to stick in the system and say, I got all the points, or I got these things and I'm going to move on. I got a certificate and I'm going to move on. Yeah, well, nobody wins in the end. But you can actually turn this to your advantage and say, right, so this is the way in which, you can make a lasting impact on the things you can do. It's only 3 lines, okay? Just do it on your own. It's just practice. Try and do it a different way. If you already think that you can do it one way, say, well, I'm going to challenge myself and try and do it in a different way. That's fine too, right? In fact, when I was with the previous thing you were coding, I overheard someone saying, let's try and use do while loop here or something like that. Yeah, okay, that is actually a great opportunity, I think, really, because in real life, I don't know, it's a 0.1% of the time you're coding, you actually use a do while loop, I think. Okay. So every opportunity you get to use a do while loop, like in a class or something, yeah, great. I think it's great to go for it. Yeah, totally. Yeah. Try all these things. The ternary operator too. If you have an opportunity anywhere at all, use it, because these things are practice for your final exam also. All right, okay. I'm going to be here. I'm going to turn this laptop around, okay? So I'm not looking at the screen. We got a lot of time. Let's say five minutes to wrap this up, okay? So what you're going to do is basically create an animation here using that sleep. I think it's use sleep, okay? Use sleep, and someone should chime in with the include file and things like that. That's it. Okay, it's kind of cool. It's under 50 lines of code, and we're actually having a nice little animation. And probably with 100 lines of code in a public site like Online GDB, we'd have a functioning game, right? Which does something that, you can do this, and that'll be really fun. You can actually share it, right? Like Isidore could send it to his grandma in Sweden, right? And it's just an Online GDB link. And, for all we know, the actual server might be somewhere in Sweden, right? Because, you don't never know where the actual machines are these days. So yeah, maybe it's his grandmother. Well, maybe she's running Online GDB from her garage in Sweden, right? So we never know. So that's really cool. So we can actually implement the whole thing here and share it with anyone. All of that is open to us these days, and we should take advantage of this. Unlike when I was a student, it's all working in silos. It's not just the absence of the internet. It's just the culture at that time is really much different from now, where students are more interested in learning together in groups. Oh, by the way, when I mentioned that, I remembered an email that Stacy had sent. This is week 11. Just one sec, okay? It's about student support services. Because it's week 11, we got these special things now. Yeah, all right. So yeah, all right, okay. Yeah, the library is now open for extended hours, okay, and has virtual Saturday research help, and which is really cool. And also remember that the library has study rooms, and if you want to do a Zoom with me, and it has a good the internet too, Wi-Fi and all, so take your laptop into a study room for 15 or 20 minutes in one of those rooms, and you'll have a good Zoom session too. The study rooms, you can reserve study rooms, and a whole bunch of other things that I don't actually understand, but there's a bunch of workshops like stress relief and stuff like that. All right. I'm sure you'll find out these details once you go to the STEM Center or something like that. They'll have a lot of details of these things. Yeah, so there's a lot of support services, I know that some students are actually hungry in week 11 and week 12, because in the past, when I was in the office in the PSEC building upstairs, I used to work late, sometimes in week 11. Yeah, I've seen students go into the kitchen and look in the microwave for things to eat, around this time. So, but that's up the hill. But we actually have a pantry down the hill. I don't know if you know. And there are places where you can actually find food on campus, even though it's late. All right. So there are things that, and best to find out before, I think, before the week, so that you're well prepared for, if you find yourself stuck on campus, that is, right? You're well prepared for all of these things. So yeah. So that's what I wanted to pass on to you, right? So there's lots of support services. Reach out to me too, or anyone on campus will be able to help you. All right. So you guys are going to finish this up. 10 minutes. 10 minutes. Now, do you want? If nobody volunteers, I'm going to finish it. Okay. So I need to see a couple of hands up at least, saying I'll take over. Okay, at least, maybe Vikram is going to hand over to someone else. How about I say, all right, now Vikram is going to fork the code, or, whatever the orange button is. You may click that orange button. Okay. And you're going to take the code, and let's say you're going to hand it to someone else. All right. Angelos. All right. Angelos, are you ready to go today? Are you still on your phone? Angelos? Great. So Angelos is going to code, okay? Angelos is going to code, but anyone can call out the code. All right. So you're going to stop sharing, Vikram, but make sure you share the URL, okay? The share URL. And Angelos is going to click that and fork the code, and he's going to start editing. And someone is going to call out the code. Maybe Vikram calls out the code. I see.
All right. I sent it.
working.
I sent the online GDB. You guys can fork it. It's from on the Zoom chat.
Okay. All right. So Angelo said, yeah, he got it. No, so the thing, Angelos, when you type something there, it just comes and goes, it disappears. I'm going to rely on someone else, keeping an eye out for what Angelo says, because he's got a not working mic. You're going to type it there, and someone has got to volunteer and say, hey, Angelo says XYZ. Okay. Speak it out so that I'd be able to see it. Angelos is just going to type out. All right. So Angelos, take the code, and then you're going to complete this function, which is going to do that animation for us. Vikram, you have a question?
Can I post the online GDB link on the Reddit?
Yeah, but for now, you can just share it on chat. I think, Angelos just needs to pick it up.
Okay. Yeah, I think he can do it, since he'll have the whole thing at the end.
Yeah. However you guys choose to do it is fine. I think. All right. Okay. So I'm not going to look at it, right? So I'm not going to call out every single detail here. You're going to take over, and show animated list. That's the part you're going to complete. Okay. So so whoever it is, Isidore or Ben or Rebecca, Kiera, Stanley, whoever, if you know what the hell needs to happen, you're just going to call out and say, all right, I'm going to take over. Can I call out the code? All right. And then you're going to call out the code like I do, and they're going to type it, and you're going to say space, curly brace, enter. That's fine. Okay. And if someone doesn't understand what's going on and say, hey, why do we need to do that? Yeah. And you would explain. That's all. Okay. Otherwise, you should keep on calling out like a robot. That's all. Okay. So I know a lot of people can do it in class. A lot of you can do it, and you're not, you're not using up your vocal cords and say, hey, that guy's paid to do it and he can talk. No, you can also talk. Although you're not paid to do it, but you'll get points. You'll get paid in points. Okay. So you should say, take over and say, I'm going to call out the code. Yeah. Hey, increase the font. Who is this, by the way? Angelos, increase the font. Yeah. Okay. That's plenty, actually. Get rid of the blue, white part, get rid of the white part. Yeah, that's actually pretty good. Yeah. All right. Okay. All right. So, and put a comment. Okay. Before I leave it in your hands, put a comment, go to line 39 and hit enter, and put a comment there, put enter and hit a comment, enter, a comment, start a comment, end the animation. End the animation when the delay between frames is more than 1 second, right? End the animation when when the delay between frames is 1 second or longer. Yeah, okay, that's all. Right, so I'm going to leave it in your hands. Is that okay? Angelo said okay. So I'm going to actually say, trust you guys to wrap this up and show it to me, right? In 5 or 10 minutes, you're going to call me and say, I'm done. Let's look at the exam, the animation. And you're going to treat me to an animation here, okay? 5 minutes. Alexa, set a timer for 5 minutes.
5 minutes, starting now.
So, based on professor's requirements, I'm pretty sure we're gonna have to do that, call that print function. Correct me if I'm wrong. Let me find it. So, wait. So we'll probably do print list.
What's going on? There's absolute silence here.
Okay, wait, everyone, I'm a little confused. Do we have to do print list, like print list?
No. So it's just two or three C++ lines of code here. All you want to do is whatever you have inside of print list, you're just gonna copy it, essentially most of it, except you're gonna take care that if the list has more than 10 elements or more than 15 elements, you're going to say ... and not keep going on and on. That's all.
All right.
Yeah. And then that's the end of that frame. And the next time you print the list again, after the /r, you're going to advance p equals p arrow next. You've done that before in the previous function, right? So the whole thing would have appeared to have moved to the left by one number. Yeah. Am I making sense to at least one person in class? Because if I make sense to at least one person, that person can actually call out the code. If I'm not making sense to anyone, I will have to call out the code. All right. Okay. So it looks like I'm not making sense to anyone. Yeah. Yes or no? Unless I'm not getting an answer either way, right? So I need to know yes or no. Right. So is it clear what needs to happen? Is it not clear what needs to happen? Eric has given me a cross. Okay. All right. So at least one person is not clear on what needs to happen. Okay. Here's what we're going to do. Okay. So one sec. Okay. All right. Okay. All right. So inside of that that animation loop, that is the animation loop. The first thing we're going to do is print out the list like we did in that other thing. So what we're going to do there is node star q. Node star q equals p. Node star q equals p. Yeah, semicolon and enter. In fact, how about this? Okay, let's do a for loop. Did we do a while loop before? Right, you did a while loop there. Okay, so I'm going to do a for loop here. Just because, okay, it's a for loop. You could do a while loop too. I actually started doing a while loop. I'm going to do a for loop. Okay, so we'll do it differently. So you'll have, so let's say for node star q equals p, right? Change that line to for. No, the previous line. The previous line for. And again, it's a new way of using the for loop. Yes, because in the past you only did for size t, for int, and so on and so forth. Now you're saying for node star p. Right? So it's a different kind of a for loop. All right. Okay. Hey, Raj, are you still confused or are you on board? All right, great. Okay.
Oh no, I didn't know it was still stuck up there.
Yeah. So like the thumbs up
I
goes
thought
away,
it goes
but you
away
know,
after like 5
all
seconds.
these
10
things
seconds.
stick around. All right. So for open parentheses, for open parentheses, for open parentheses. After the for, you have an open parentheses. Yeah. And get rid of the closing parentheses right there, because for node star q equals p, node star q equals p. Right? Okay. Now, and then after the semicolon, Alexa, stop the timer. Right? And then you're going to say q q is not equal to null pointer. Okay, q is not equal to null pointer. Q is not equal to null pointer. Q, oh, I see. Is not equal to is exclamation mark equals. Yeah, you got to practice that a lot. Exclamation mark. No, not is that a vertical bar or an exclamation mark? I can't tell. Is it a vertical bar or an exclamation mark? I can't tell.
An exclamation mark.
All right, okay. So I can't tell from here. All right, is not equal to null pointer. Is not equal to null pointer. Yeah, null pointer. No, I think it's a lowercase null pointer. Yeah. And so it's a compound condition, okay? And num items printed. And num items printed. No, double ampersand, okay? Not so the single ampersand is actually a bitwise and. You'll be doing a lot of that in in CS2B when you have to take bit patterns and change bit patterns and all. You'll do the single ampersand in CS2B. And sometimes it actually works because one single ampersand also, but it's bad practice. Double ampersand is logical and. Yeah, double ampersand. Ampersand. And num. No. Just two. No, hang on. I think you got an ampersand percent there. Actually, you know what? You got to increase the font size one more time, right? Because I've got half my screen is taken up by your, Actually, why am I even bothering? Because all of you guys are just rectangles at this point. Yeah. Okay, that's much better. Yeah. All right. Oh wow. Okay, that's what you guys see. All right. Okay. All right. Okay. No, ampersand. One more ampersand. Okay, not percent sign. Yeah. Previously, no. I still see the percent sign. Oh, something is funny here. Do other people see the percent sign, or is it just me? It's just my.
No, I can see it too. Yeah. Okay, it's
Okay.
better.
Because maybe your keyboard is escaping these things and sticking percent in front of that. So I don't know. Right. Okay. Right. So yeah, double ampersand. You want to say num printed is less than 10. Okay. Num printed is less than 10. Num underscore printed less than 10. Less than 10. Okay. Less than. No. Less than, not left, no, not shift. Less than is less than sign. Okay. I think it is shift comma. No, that is greater than, less than. Yeah. All right. Now, in fact, instead of num printed, you say num printed plus. Okay. Say num printed plus. Okay, less than 10. Right. At the end. Yeah, semicolon. Q equals Q arrow next. And put spaces around. Yeah. Right. Now, here's the thing. Okay. The code we write today, maybe we won't have time to test it and compile it and so on and so forth. Maybe it has bugs in it. Now, there's extra credit in here for guys to take it and say, hey, here's the code. We fixed some bugs. Like Ria took some code in class a long time ago, I think, right? And there's a bug in here, size T or something like that. Division won't work. So, and other people have done that too. So if we have bugs in what we're writing today, you get extra credit or, great things to put in your final report. of, taking this and fixing the bug and then posting it. Yeah. Okay. All right. All right. Oh, close the parentheses. Close the parentheses. And then curly brace and enter. Space curly brace and enter. Yeah. All right. Space curly brace. Enter. All right. Now, you want to say C out. Left shift. Q arrow. Q, no, left shift, left C out, left shift. Left shift is less than, yeah. Left shift. So something tells me you need a lot of practice. Okay, Angelos? Right, because these are things that you have to be like, it's second nature in the, the final, obviously, right? But certainly for the lyric quest and all, you can't do the quest and then get it right, but then you have to keep doing it again and again until all of these are like practiced enough. Okay, C out, left shift. Yeah, Q arrow data. What is it? What do we call it? I've forgotten. Is it Q arrow payload? Q arrow payload. Left shift. And then a hyphen. Yeah, hyphen. Hyphen. Dash. No, dash within quotes. Yeah. Double quote, dash, double quote, double quote, double quote, double quote, double quote. Yeah. Shift, a single quote is double quote. It's right next to the return key. No, not double quote. No, not that. It is the key next to the return key for me. All right, it's the double quote when people are talking. No. Right? Okay, backspace. There you go. All right. Except on the left side you have right shift, right? Two greater thans. There should be two less thans. On the left side, yeah. No. You see there you go. Yeah, those things there. The two greater than signs should be two less than signs. Yeah, that's left shift. All right. Now inside of the double quotes, you need a hyphen. A hyphen is a dash. All right. And then go to the end. Now let me run this through in my head. Okay. For a number and then a dash. All right, you know what? We're not going to keep the exact count here. So on the next line, so after the for loop, yeah. In fact, there's only one line. You can get rid of the braces and all. You can get rid of the braces. There's only one line in the for loop. Yeah. Yeah, get rid of that. And also the opening one also. Line 42, end of line 42, get rid of the, no, not there. Oh yeah. All right. So all right, go to the line 45. Yeah. And back one, one indent back. Yeah. All right. Now what we're going to do is if Q equals null pointer. No, within parentheses. Okay. See, especially if you're a Python programmer and all, you got to get in the practice of doing these things. Okay. In the final, you won't have time. If you have a program fragment and say, hey, is this, syntactically right? And you're a Python programmer and say, hey, that looks good to me. Like, Angelos just did, no parentheses. But unless you've practiced enough in C++, that won't look out of place to you. Okay, so that's what I mean. So these kinds of things should just come naturally, and that will come only if you've done a lot of coding. So that's how I can tell when you've actually been doing a lot of homework or coding a lot, because it's not that it's bad and all, but I mean that you do have competing interest in your time, for your time, but you have to be like super duper committed and make sure that before the final you do what it takes to get utterly comfortable and familiar with these things. All right. If Q equals null pointer, double equals, double equals. Yeah, null pointer. Yeah, on the next line. Yeah, indent in, indent in. Indent in, tab, tab, tab. Yeah, and you're going to say C out, and then left shift, the word NULL. Okay, all uppercase. Left shift, and then the word NULL. And within double quotes. Yeah, within double quotes. And then all uppercase. Right? Yeah, okay. Yeah, all right. So semicolon, 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 right? Enter, enter. Else, backspace one time, backspace one time. Right? Else, ELSE. Yeah. No, yeah. No, lowercase. How come it's is online GDB automatically correcting these things with uppercase the first letter? Maybe your language is set to something other than C++. I don't know, right? Because I saw that uppercase else, maybe in some other language. Yeah, hit enter, C out, enter, tab in, C out, left shift, Q arrow payload. No, not within quotes. Q arrow payload, Q arrow payload. Yeah, and no spaces around the arrow. Yeah, it is, That's it, right? All right, semicolon, semicolon, semicolon. And you can get rid of the spaces around the, that's okay. Yeah, get rid of the spaces around the, arrow on both sides of the arrow, because, this is an operator. All right, okay. So now outside, hit enter, and then back one. All right, put a comment there, All right, extra credit, put in a comment. Right, extra credit, refactor the above code, maybe use ternary operator, etc. Okay. Actually, no, just say extra credit. Otherwise, people are not going to do it. Right? Whether I give out the extra credit or not. That's funny, right? Extra credit, right? And then colon, refactor the above code, refactor, simplify, maybe use a ternary operator. Refactor, comma, simplify, comma. Yeah. And what was the other one? You may maybe use a ternary operator. Okay. No, I think I should just say refactor, simplify. Ternary is your choice. You should be able to do it, right? Yeah, that's fine. Okay. So on the next line, right? So that's it. That's all. So on the next line, we've printed this. All right. Now we want to send a /R. C out, left shift. C out, left shift. /R within double quotes, /R within double quotes, double quotes. Yeah, /R. No, /R, /. Yeah. Backslash. Should be close by. Yeah. Backslash is above the return key. Like this. R, /R. All right. And then at the end, you're going to, send flush, right? So, yeah, left shift flush. Yeah, left shift flush. All right, semicolon. Right. On the next line, you're going to sleep. No, you sleep. I think someone has got to, do some research and correct me if I'm wrong here. Okay, you sleep. Yeah, you sleep. 0.1 seconds. So, and it's microseconds. So it's 10 to the 6. Okay. So, yeah, you sleep, delay times. Where are you, by the way? I can't even see where you are. Angelos, you got to type, okay? Because I'm just calling out the code, and in the assumption that you're typing these things. You sleep. Okay, open parentheses, right? And in there, you're going to say delay times 1000 times 1000. Microseconds, okay? Times 1000. Times 1000, and then you can say in comments, semicolon at the end, and then put comments. No, that's great. That's great. Yeah, that's okay. Semicolon at the end, right? And then a comment there that says microseconds. Put a comment, yeah, comment microseconds.
Hey, Professor, it's 8 p.m.
Oh, it's 8 p.m. already? Okay, but give me a thumbs up, or someone should say, yes, I understand what we're shooting for. Okay, because I think at this point it's pretty close to the end. You all have a very good idea of what we're going for. Yes? Can you complete this and share it? Yeah, Spencer says yes. Okay, Isidore, yeah, all these other people, most people are gone. Okay, please complete this and share it. Thank you, Justin. Share it in the forums. We'll meet on Tuesday, okay, just on Zoom. If nobody wants to meet in class and it's not raining, I don't know. We'll meet on Tuesday and complete this and actually have a game. All right. Thank you all for sticking around. And Angelos, thank you so much for coding. Make sure you code this, share that orange link. Okay. The orange link, share that code. Not just a link, bare link. You should say, this is the code for the game. We need to complete it. You got to do a little bit of explanation and then post it on Reddit, and people will take it and share it. Yeah, and take it to the next line. You should also feel, free to complete this code, right? Have the animation and share the completed code. Yes, Angelos? I don't know. Well, because he can't talk, he'll probably say something in yes. Okay, he says yes in chat. All right. Well, thank you all so much for sticking around. I hope I'll see you guys on Tuesday. Okay. Hey, Kira, Kaden, Brian, Julian. I don't know if you guys are still, awake and here. So yeah, give me a, one of those. Yeah. All right. Thumbs up from Kira, Brian. That's like claps and all, right? Like, oh, actually, do I get anything like that? No, this is, how come this doesn't help? Maybe one hand like this. No, fireworks. I thought I got fireworks by doing this. Oh my gosh. Oh, wow. Oh, that is fireworks. So confetti. There's something for confetti. This is funny. It's actually interesting. And it's interesting that you can forget these things too. Because then it's more like a game. Every time, try these things out in a meeting and it's fun. All right. So, hey, Dylan and Juliana, are you guys okay? I haven't seen the thumbs up from you guys. Okay. You guys okay? Juliana. All right. All right. Okay. All right. I will see you guys on Tuesday on Zoom. And then we'll go from there. Okay. On Thursday, if everything looks good, we'll just meet in class. Okay. And I'll make it worth your while, I'll get some pizza if it's a cold day. See you guys later.